Usually in Kafka ecosystem, producers push data into Kafka, and consumers pull that data from the Kafka broker. However, there are situations where we need to move this data to external storage systems, for example, storing logs in S3 bucket and vice versa. We may also need to ingest data from files, databases, or other storage systems directly into Kafka. In such cases, we don't want to rely on consumers or producers to handle this data movement. Ideally, we want the process to be automated. That's exactly why Kafka Connect was created. It enables automatic data integration between Kafka and external systems. Kafka Connect helps us move data from various sources directly into Kafka or from Kafka into external systems without requiring custom producer or consumer code. So what exactly is Kafka Connect and how does it work? Kafka Connect is a framework that's a part of Apache Kafka. It provides scalable and reliable tools to stream data in and out of Kafka without write custom code. Instead of building producers and consumers for every external system, you can use Kafka Connect with pre-built connectors. There are two types of connectors. Source connectors, which pull data from external systems like databases, file systems, or APIs, and push it into Kafka, and sync connectors, which take data from Kafka topics and write it to external systems like S3, Elasticsearch, or relational databases. For example, if you want to send all your Kafka topic data into a S3 bucket, you can use an S3 sync connector. If you want to stream data from a PostgreSQL database into Kafka in real time, you can use a Postgres source connector. And the best part, most of the configuration is done through simple JSON files or REST API calls. No need to write any Java or Scala code. Kafka Connect can run in two modes: a standalone mode for simple single node setups, great for testing or development, and distributed mode, which is production ready and allows scaling, allow fault tolerance, and centralized management. Kafka Connect also handles schema management and integrates with schema registry, so it works well with tools like Apache Avro, Protobuf, or JSON schema. This helps ensure compatibility between systems and makes it easier to evolve your data models over time. Kafka Connect is a framework which helps to integrate and host connectors, which are responsible for moving data in or out of a Kafka broker. A single connector is essentially a plugin that we need to install, and then we specify in the Kafka Connect configuration the path to that plugin so that Kafka Connect can use it. So let's talk about the workers and tasks, which are essential parts of how Kafka Connect operates behind the scene. A worker is basically a running instance of Kafka Connect process. It's responsible for managing connectors and coordinating tasks. In distributed mode, multiple workers can be grouped together to form a Kafka Connect cluster. This allows of scalability, fault tolerance, and automatic load balancing. If one worker fails, the others will take over its tasks, ensuring your data pipelines remain operational. Workers communicate with each other using Kafka itself, storing configuration and state in internal Kafka topics. In distributed mode, Kafka Connect stores critical information in dedicated internal Kafka topics. Connector configurations are stored in the config storage topic. Task and connector statuses are stored in status storage topic. Offsets, which track the position of data being read from source systems, are stored in the offset storage topic. These internal topics allow Kafka Connect to persist state, recover from failures, and coordinate across workers efficiently. Now let's talk about tasks. Each connector is split into one or more tasks. Think of tasks as actual units of work that do the data movement, either pulling data in or pushing it out. For example, a PostgreSQL source connector could be split into multiple tasks, each reading from a different table or partition, or an S3 sync connector might use multiple tasks to upload data from different Kafka topic partitions in parallel. So you define the maximum number of tasks in the connector configuration, and the Connect framework distributes them across available workers. The parallelism helps improve throughput and reliability. Alright, so before we're gonna go on with our hands-on, we need to download our repository where we have our projects. So you don't need to write anything on your own, everything is already done, so everything you need is just to clone this project. So let's just copy it and let's go to the terminal. You could choose your folder and just clone the repository. It could take a while, so yeah, I will stop the video and we will move on. Okay, so let's talk about Kafka Connect Standalone Mode. As we discussed earlier, Kafka Connect has two modes, distributed and standalone. Standalone mode is mainly used for development or testing purposes. The key difference between standalone and distributed mode is how offsets are stored. In standalone mode, Kafka Connect keeps the offsets in a local file, whereas in distributed mode, offsets are stored in Kafka's internal topics. When we start Kafka Connect in standalone mode, we specify the path to that offset file in the configuration file. Now let's take a look at our standalone setup. In the Docker Compose YAML file, we have three containers: Zookeeper, Kafka, and Connect Standalone. Kafka and Zookeeper together form a small single broker Kafka cluster. We don't need to focus too much on them. They are simply to provide Kafka for the Connect instance to work with. The third container is Connect Standalone. In this container, we start Kafka Connect using the Connect Standalone script from the Kafka binaries directory. So, as we discussed earlier, Kafka Connect is the part of Kafka, so we don't need to install any external dependencies. So we pass two arguments to this script: the configuration file for Kafka Connect itself and the configuration file for the connector. So now let's dive into the Kafka Connect configuration file to see what each part does. So let's take a look at the Kafka Connect configuration. The first property is Bootstrap servers. This defines the Kafka cluster we want to connect to. It tells Kafka Connect where it should read data from and write data to. In our case, it's pointing to the Kafka broker running on a port 9092. Next, we have key converter and value converter. These properties define how data is serialized and deserialized when it is written to or read from Kafka. For example, we can use string, JSON, or other converters depending on the data format we need, but we are using string because it's just simpler for us for our use case. The following property, offset storage file name, is one of the most important in standalone mode because it specifies the path to the local file where Kafka Connect stores offsets. This file allows Connect to keep track of which records have already been processed. Finally, we have plugin path. This property specifies the location where Kafka Connect should look for connector plugins. In our case, the plugins, Kafka connectors, are located inside the container. However, we mount a volume from our local machine into the container, which allows us to manage the plugins directly from our local environment. The next file we pass to the script is the connector configuration. And in this case, it's a file source connector configuration. This connector is responsible for reading data from a specified file and writing the data directly to Kafka into the topic defined in the connector configuration. Let's break down the configuration. So let's go to our configuration file here, and here we have name property. This is the unique name of the connector. In our example, it's a file source. The next one is the connector class. This is the fully qualified Java class name of the connector we want to use. Kafka Connect will look for this class in the plugins directory we specified earlier by the plugin path property right here in the Kafka Connect configuration. It's crucial to specify this class name because it tells Kafka Connect which connector implementation to run. The next property is tasks max. This defines the maximum number of tasks that the connector can run in parallel, but for our simple case, one task will be enough. The next property is a file, so this property defines the source file path from which the connector will read data. In our case, it's data/input.txt file, which is right here. And the last property is topic. This is the Kafka topic to which the connector will write the data. In our example, it's file input. So we are reading data from that file, input.txt, and writing directly to the file input topic. So this configuration ensures that data from the specified file is ingested into the Kafka topic for further processing. Alright, so let's try to start it up. We have a steps file prepared for you, so you don't need to write commands manually, just copy and paste commands from the file and that's it. So the first step is to start Docker Compose. Let's copy the Docker Compose app command and paste it right here in the terminal. It may take a while to pull the images because I already have these images on my machine, so it's take like few seconds to start these containers. However, if you don't have these images on your machine, and you don't have probably, it will take, I don't know, maybe a few minutes depending on your internal throughput. So just wait while Docker pull these images from Docker registry and you can move on. After your Docker gonna pull these images, you will have your Docker Compose app. Let's verify, do we have these containers with the Docker PS? So let's just type Docker PS here, and you should see 3 containers: Zookeeper, Kafka, and Kafka Connect. The next step, it's actually, you don't really need to do in the next step, just little explanation in Docker Compose YAML. So let's go to the Docker Compose YAML. In the Kafka Connect container, we define the startup command in the Docker Compose file. This command runs the Connect standalone script and passes 2 configuration files we discussed earlier. It's one for Kafka Connect itself and one for the connector configuration. This means Kafka Connect is already running and has automatically loaded the connector with the configuration we provided. So let's move to the next step. Let's back to the steps file and copy this command with docker exec. This command will get you inside Kafka container, where we could verify what we have in our topics. But we need to produce some data. The connector we configured is a file source connector, which reads data from the file we specified right here and writes it to a Kafka topic. So let's go to that input.txt file and write some messages. So it could be 1, 2, 3. Let's back to our steps file again and copy that command and paste it in the Kafka container right here. And yeah, as you can see, we have our messages from file in that topic. That means that connector is working properly. You will see the data being consumed from the topic in real time. So any new lines you add to the file will immediately appear in the Kafka consumer output. So let's add new messages. And as you can see, we have got new messages as well. So yeah, that's it. When you have done with testing, don't forget to shut down everything properly. In steps file you have docker compose down command, so let's copy it, let's paste it, and yeah, this stops and removes the container and volumes, keeping your environment clean. Alright, in this section we are going to implement our sync connector. As a quick reminder, a sync connector is a Kafka Connect component that takes data from a Kafka topic specified in its configuration and writes the data to an external system. In our case, that external system will be a simple output file on a disk. This is the reverse of source connector, which ingests data from an external system like a file, database or API and pushes it into Kafka. To make the example more illustrative, we are not going to implement only the sync connector. Instead, we will create two connectors, a source and a sync, so we can see the full round trip of data. The source connector will read data from an input file and publish it to a Kafka topic. The sync connector will consume data from that same Kafka topic and write it into an output file. This setup will clearly demonstrate how Kafka Connect works in both directions. By the end of this section, we will have a working pipeline where data moves seamlessly from one file to another via Kafka. No manual intervention required once the connectors are running. This is exactly the kind of automation Kafka Connect was designed for. And the file-based example provides an easy way to understand the underlying concepts before moving on to more complex systems like databases, cloud storage, or APIs. Alright, so let's move on to the file sync project. Just like before, we are running a Kafka single broker cluster. That means we have got Zookeeper, Kafka Broker, and Kafka Connect all ready to go. So now open up the steps file in your project. There is where we've got all the commands we will need. We have done this plenty of times already, but let's do it again. In your terminal, paste the docker compose app command. This starts all the services. Give it a few seconds and yeah. This connector we are going to apply is a file source connector. As we already did it a lot of times, it's just read the data from a file and send it to a Kafka topic. So we are gonna produce data to the file topic. We define it right here, and our source file, it's just input.txt file defined right here. So let's just copy and paste it in your terminal. If it will works, Kafka Connect will respond to you with some JSON confirming that the connector has been created. But let's check it with a REST API call. So let's just check the list of our current connectors. So let's just copy that command. And if you will see the list with the file source inside, it means that we successfully created our file source connector. Okay, so let's add a new messages to our input file. Let's go to our input.txt file and let's type something like 1, 2, 3, whatever we want actually. And now let's read the messages from the file topic. We need to copy that command to get inside a Kafka container. So let's just copy it and paste it right here. And let's also copy that command to consume the messages from the file topic. So let's copy it and paste it. And as you can see, we have our messages right here. Alright, so once we have done this, let's apply our sync connector. So this connector gonna read the data from that topic we defined right here, and it gonna put messages to the output file we defined right here, to the output.txt file. So let's just copy that command and let's just paste it in the terminal. So as you can see, we added. Let's verify by checking the list of our current connectors. So let's just copy that REST API call, and after pasting, you can see we have a list with our connectors. So we have file source and file sync connectors. So it means that we already have our connectors added. Alright, so that's actually it. Let's go to our output.txt file, and as you can see, we have our messages right here. So the same messages we have in the input.txt. So what's happened? We have two connectors, which are first, it's a source connector which reads messages from the input.txt file and pushes it right to the file topic inside Kafka. And the second connector reading that messages from that file topic and put it right to the output file. It works in real time, so we could add new messages right here. So let's go to the input.txt and let's add new messages like 4 or 5, and let's go back to the output.txt, and as you can see, we have everything up to date. So everything works as expected, and now I hope you understand more how these connectors are working. It's really simple, and I hope it's now clear for you. Don't forget to turn off your Docker Compose with the Docker Compose down comment.